Check, check, 1 2 1 2. Check, check, 1 2 1 2. Hello, hello. How's it going?
What's going on? Jake said he's going to be in later.
Okay. No problem. You guys excited about Friday?
Yeah.
Huge plans for the weekend?
No,
Maybe hang out at the house?
I got a lake nearby. I'll probably go there for a little bit.
Oh, nice. Do any fishing?
Yeah.
What kind of fish are they?
Well, there's catfish spawning right now.
No, nice. Fry some up. You eat them or you just catch them?
Release, honestly.
Yeah. Yeah, that's how I am most of the time too. It's more fun to catch them than clean them and cook them.
That's right.
Oh. Well, 10 o'clock. So I was just going to probably have a pretty quick one today. Basically, I just kind of wanted to talk about how to do part number 4 on the also boring head. That's the threaded shaft that goes in the head of it that you make your adjustments on. So I wanted to talk about that, and then also part number, what is it, 5. So that's another piece that goes on the head, but this one is more of a, well, this one right here, right? So that one has kind of the tricky part with that is there's just a pattern you have to make on there. So we're just kind of going to go over that. But probably will not be the full hour or really anywhere close. So let me resituate some stuff. And there we go. Okay, so this is, I already kind of got started a little bit on the, this is, well, hopefully, obviously, part number 4. Not the whole solid model. I didn't import the model. I just drew up the basic outline of this guy. So to do this with the model would not be substantially different. Pretty much be the same sort of scenario. You're just gonna probably have to draw in some lines, some vertical lines, and possibly some horizontal lines. But you're really just connecting the dots. So just to kind of go as a review, let's just go ahead and do the whole thing. So obviously, if you can see my stock outline, we got a 3/4 inch stock. This guy finishes the largest diameter at 675 at that shoulder there. And then this is going to be 3/8 40 thread. So to get this guy, we'll just do a quick face. I'm not going to really go through all the settings and everything since pretty much there yesterday. Just kind of go over it quick. So if you do want to review, you can. If you do want to review, you can come back and check it out. So, like I said, nothing really a whole lot different than what we did yesterday. Well, let's try that again. What the heck am I selecting down there? That doesn't look right. Okay, let's try this one more time. So I'm just going to rough that and then finish over there. There we go. 3rd time's a charm. Rough parameters, again, we're not gonna, we're not really too worried about all that, but you know me. All right, so we got that guy roughed out, and then we're going to do a finish pass. Let's do our last chain, and there we go. All right, so basically we got this guy roughed and finished, and now it's time to thread. So threading is actually pretty straightforward. It's kind of like on the CNC lathe. Sure beats the heck out of manual threading. Manual threading is the worst, right? So there we go. So when we go to the threading, right, our tool's obviously going to be different. Not going to be able to thread very well with your 55-degree OD turning tool. So the parameters that we really need to worry about here are basically most of them here, right? We're not going to change our included angle or a thread angle, but our lead is definitely going to change depending on what kind of thread we're cutting. So for you guys that just hopped in, we basically we're on part number 4. We did a quick face, rough, and finish turn on the body of this guy, and now we're going to now we're going in through the threading tool path. So threading tool path, like I said, it's pretty straightforward. Obviously changing tool numbers and all that's going to be important. So we'll just change this tool number 2. Feed ray spindle speed. Don't know why it will not let us. Huh. That is interesting. All right, so won't let us do constant surface speed. But all right, so let's say 1500 RPM, max spindle speed. Let's say 3000. I don't know why it has a max there because we're not doing constant surface speed. Anyway, all right, so we got our lead, right? So our lead on this is not necessarily our lead. This is one thing that kind of annoys me with these parameters. So it says lead, but we can either put threads per inch or inches per thread. So we can put threads per inch or our pitch or lead. Even though it says lead, you can put in threads per inch if for some reason the math is too hard for you. All right, so we got 40 threads per inch on this guy because we're cutting a 3/8 40. And then our start position. So our start position is going to be where our thread starts, right? So we can click on that and our thread is just starting right there. That's not going to be where your tool starts. Okay, that's just where the thread starts. Once we get all of our parameters set in this window, then we'll go over to our thread cut parameters, and then that's where we can adjust like where our tool is actually going to start its motion and that sort of thing. Then our end position with this guy, we're not actually ending like at the shoulder, we're ending in a spot back here. So if we look at our print, this is 1/4 of an inch, 250 thousandths. Then we're going to have 1 inch, 700 thousandths worth of thread. So instead of clicking on this, I'm just going to use my amazing math skills. All right. So 1.7 inches of thread and then a 1/4 inch of knot thread, right? Because this is going to be an absolute position on our part, right? So this isn't how long our thread is. That's not what they're asking. What the length of our threaded portion is. They're asking where the end of this is. So we're starting at -1/4, finishing at 1.7 back from that. So that's where we get those numbers. So pretty straightforward.
So I did notice on your print when you were going through actually drawing this part in SolidWorks, there was a weird discrepancy of that like extra 1/4 inch on the front. Our print, when we were looking at it, didn't look the same way. I don't know what the deal was there, but
yeah. So I was actually looking at a print. That's a good point. Yeah. So when I was going over the SolidWorks part, I was actually looking at a print that I got off of the shared drive, the employee shared drive, and for some reason that print kind of got blown up. I don't know if it was remodeled or at some point, but the print was basically the datum on that print was off of the part, so it looked really weird. And I figured that's what it is. But yeah, you're right. The print that's on Inside Rank, and that's the one I'm looking at right now, and there really aren't any problems with that, so shouldn't have any issues. All right, so thread form up here, right? We can kind of do this a couple different ways. My preferred way and the way I'd like you to do it is to get your, if you have it with you, is to get your machinery handbook and look it up, right? So in our machinery handbook for this guy, our major diameter is 374 to 369. Well, if we use 373, that puts us in our tolerance for the shank of this guy. So this is going to be cut 372 to 374 all the way across. So if we put it kind of in the middle there, that's still in our thread form tolerance, and it's also works for the diameter tolerance on that. And then our minor diameter is going to be 0.3443. All right, so that's what I got out of the machinery handbook. 28th edition, kicking it old school over here. So what we could also do is you can also select from a table. So like your thread form, if you select from a table, this little guy is going to pop up. And so our first option is UNRC and UNRF. A 3/8/40 is definitely not in that category. It would be in the extra fine. So UNR, UNRC, UNRF, UNREF. So UNRF is unified thread form fine. EF means extra fine. And so this is actually going to be in the EF category. If you look in your book, it's actually UNS, I believe. Yeah, so UNS is a Unified National Special thread. It's a very special thread. I feel like this is a very special episode. But if you look at this thread form, it's not going to be as accurate as what you get in your machinery handbook, right? And so, like here for major diameter is just the nominal major diameter, 3/8 of an inch, and for minor diameter is actually almost 1/1000th off of what we get from the machinery handbook. So, is that going to make a huge difference? Probably not. But if you're doing this, you might as well go with the most accurate, right? And also, anytime you're making a thread, you should be writing that down on your print so you can know your major and minor diameter, and most importantly, your pitch diameter, right? So you can measure that guy in. All right, so from there, I believe we are good. Don't need to do anything, right? We don't have a taper angle. We could cut a pipe tap thread. We could have ID or OD threading. We can even have a face threading. Never done that, but sounds cool. All right, and then our thread cut parameters. So we have a few different options here. So longhand, can, box, alternating. So longhand, what that's going to do is it's going to output this. Well, I guess canned is, we'll start with that. So canned, what that's going to do is it's going to output this as a G code, right? So it's a can cycle for the lathe. So it's going to generate a significantly shorter program. But if you didn't want that, like if you wanted, instead of having a can cycle controlling that threading, maybe you're on a different machine that doesn't handle that quite as well, what you can do is do what's called longhand. So longhand is basically going to write out the code for every single pass. So it'll write the code out, G1, feed this rate, and do every single pass like that. I can't remember what box was or alternating, but basically the big thing is probably going to want to do canned. I can't really think of a reason why you wouldn't want to do, especially since we're on our Haas. Haas's will handle it just fine. Determine cut depths from, so equal area or equal depths. So when you're cutting threads, obviously we're going to have an in feed amount, right? It's going to feed in. It's going to feed in a certain amount on each cut. So it's typically going to do that from the can cycle. Going to determine how many cuts to make. What this is going to do is it's going to say, do we want the amount of material coming off of this part to be equal, like the chip thickness? Do we want those to be equal for every cut, or do we want the radial depth to be the same on every cut? So in order to control your cutting pressure, the better, probably better way of doing this is do an equal area. Otherwise, if you have equal depth, your cutting pressure is going to get significantly heavier as you get further into this cut, right? We've all manually threaded, so we know what this looks like. If you're feeding in the same amount each time, there's more of the side of that tool engaged the deeper you get into your cut. So your chip gets bigger and bigger as you go in. And so because of that, to keep our, the stay inside tolerance, to keep everything nice and accurate, we typically back off on our infeed as our thread gets deeper. So that's what equal area will do. Define number of cuts, 5 might be fine for that. I'll just bump it up a little bit. So obviously that's going to be the number of passes it takes. Stock clearance, that's how far it's coming up in the diameter, how far it's moving up radially off of your part before it makes a clearance position. The good news is this is determined off of the OD, or determined off of the outside diameter versus sometimes when you manually program this, depending on where you set up and stuff, you can base that off of the minor diameter, which is always fun. So overcut is how far it's going to go past your the end of your thread, right? So like if your thread ended right here, but you were threading into a groove, right? That's basically what you do. I'm not sure why you would dimension this way instead of, or chain it this way instead of chaining it a little bit different, but anticipated pull off. So this is, if you notice there, this is where kind of like if we tapered the end of our thread, this is where that's going to happen. So that's basically just, you can do inches or revolutions, and I would say just, make it 1/8 of an inch or something like that. Basically that's just going to come, and so instead of coming to the last thread and then pulling out, which is going to make a kind of an impromptu groove, this is going to make a nice little tapered finish. So it's going to look more like what an actual screw would look like. Acceleration clearance, I haven't used the compute. So acceleration clearance is basically just the amount that this tool is sitting off of our part in Z before it starts moving, right? So obviously, it kind of takes a little bit of time for your machine to catch up. Unless you are, I really can't think of a reason why not to have this acceleration clearance a little bit more than normal for our uses. I mean, if you are doing production, you would want this to be as little as possible, as little as is required for your machine. In our case, exactly. Why mess with it, right? And then lead inlet angle, right? So that's what you would, on manual threading, that's what you're setting up the compound at 29.5 degrees. And then up here, amount of last cut, I like to set the, our last cut at like 1 thou, something like that. And also if we had a multi-start thread, we could adjust that up here in the top right, where we could have multiple starts, 2, 3, 4, whatever. Makes that a lot easier. And then so once we click OK, one of the things that we should see here when we look at our toolpath is this will actually make a impression of what this thread's going to look like. So, but other than that, that's pretty much all there is to it. It's really just kind of like all your other toolpaths. It's really more just knowing what this toolpath is going to do. You can see this is where we're pulling out of our part there, kind of making a little bit of a taper. So that's pretty straightforward. Anybody have any questions on that? Okay.
I'm good.
So, well, I went a lot quicker than I thought it would. So from here, let's go ahead and move over to, oops, why is my screen sharing paused? Oh, that's why. There we go. Okay. All right, so this is part number 5. And boy, what the heck happened to my circle? That is funky. Why is my proportions on this are like all off? Does that look weird to everybody else?
A little bit, yeah.
All right. Well, trust me, this is round. I think it's the because I have my screen share on, that's messing up the proportions. Maybe I'm not sure. I just drew this morning, so I know it was correct at that point. So in order to draw, basically the general shape of this is pretty straightforward. Yeah, this is 440 thick. A lot of people make it out of brass because it looks pretty. You're welcome to do that. And then the only other thing on this well, it has some holes on it, but we'll skip that. But basically what well, now it's round. What the hell? All right. But basically what I wanted to show you was how to make these grooves, right? So there's an engrave. If we look at our print, I wonder if I can pull up the print real quick. Well, there we go. All right, so that's our print. All right, so we have, what I'm talking about is this little dial that goes around, right? Same thing has been on every boring head that you've used. You know, we have our thread that we just made is a 40 threads per inch. So each turn of that is going to move at 25 thousandths. The lead on that is 25 thousandths. So every mark on here is going to be 1/1000th of an inch. So what we want to do is we want to make these, and if you look at the instructions, every fifth mark is longer than the rest, right? It just makes it easier to see. Makes it just a little bit easier to see where every fifth one is, right? So in order to do that, basically what we're going to do is we're going to make a circular sketch pattern. So I can do that as in a sketch, or I can do that as a feature, right? So I can, just like in Mastercam, I can do a feature pattern, right, where we might have a tapped hole, or a hole, or some feature on our part that we want to repeat through it. It's basically what we're going to do here. So first step is we just need to make I'm just going to make a circle, and this is going to be a construction circle. Is that actually called out? No, it's not. So I'm just going to make a circle for construction. So it just means that if I do any sort of extrusion or anything, SolidWorks is going to ignore that. And then from here in my sketch, what I'm going to do is I'm going to draw a long line. And well, here I'm going to change that just a little bit. All right, so I'm going to draw a line from that point there, and then I'm going to draw a line out here. So straight up is 90 degrees. So if I draw a line out here, and again, I'm going to make this a little bit shorter. If I go back to my parameters. So if I want to separate this out into 25 equal parts, I would say 360 divided by 25 is going to be 14 degrees. And I would say 90 minus 14 degrees is going to equal 75.6 degrees. All right, so all that did was just create a line that is 1/25th of this circle and moved it over. All right, and so now what I'm going to do is I'm going to do another circular sketch pattern just on this one circle. And hopefully you'll see why I'm doing it this way in just a second. So what we don't want to do is just copy the same line, because that's going to keep this line the same. And if I change any of the other lines, it's going to change all of them. So I actually have to have a separate piece of geometry or a separate line there in order to be able to do this. So from here, I'm just going to go to convert all. I'm going to go to circular sketch pattern. And I'm going to change this to 360 divided by 25, right? Still 14.4. And I'm going to I'm going to have 4 instances of this. So one of the things with the circular sketch pattern is it's going to include your original part, or whatever you're trying to space. or pattern. So this line is 1, 2, 3, 4. It's not going to create 4 copies of that line. It's going to create 4 instances of that line, including the original instance. All right, so now we're there. I'm just going to leave that there because that's keeping that as it should be. And then I'm going to create a, because I don't want this full line, I'm going to create a circle and I'm going to trim. So, oops, what the heck? All right, maybe I need to break. All right, well, I guess we're going to leave those lines. It's really not that big of a deal. Oops. So now we have basically our 5 different lines. I know there are 4 of them are the exact same lines. Let's get back here. So now we have those 4. What we can do is actually select all 4 of those lines, or sorry, all 5 of those lines. So we got 1, 2, 3, 4, 5. Don't know why it's taking so long to click. And now we're going to do a circular sketch pattern again. So we're going to pattern a pattern here. And if we do 5 spaces of this, right, because we had 5 units, we multiply that by 5, that's going to end up as 25 separations. And we click OK. And now you can see we have long lines and short lines. And so this is enough to engrave this on here. The actual engraving portion, well, tell you what, how about I'll go back and let's go back and I'm gonna actually do this where it would be, we could actually use this as an extrusion. So right now, all these are patterned. So what I'm going to do is I'm going to double click on that. If you look on these, we talked about this before with the relations, sketch relations. When we're in a sketch, all of our sketch relations are displayed as these little boxes that are next to our lines. Like this has a vertical sketch relation, vertical. This is a coincident, and this is a patterned sketch relation. So if we double click on that, it's going to open up my display delete relations. And from here, I can just delete this patterned. And what that's going to do is going to allow me to delete all these. All right. So basically what I want is I just want my first one and my original. And what we're going to do is we are going to do an extruded cut here. Well, actually, we won't do an extruded cut. We will do a swept cut. All right. So before we do that, we need to create a sketch plane. So, well, we'll just have to create one since I created this in the middle of my part. Right. When I hover over my front plane, I can see that this is coincident with this point. So what I'm going to do is I'm going to actually normal to that guy, and I'm going to create a sketch on this. So right now, if I create a sketch, I'm going to do a midpoint line. And then I'm going to create basically I'm just going to create a triangle. And then we will say, all right, we're going to engrave this. Well, that's 5 thousandths deep. So let's say 5 thou. right, so I can close that sketch. Now I'm going to go to my features and do a swept cut. So that is my profile that I want cut, and then it's going to ask me the path that I want to cut that on. Oops, not that one. Why? What in the heck?
Maybe clicked on the small one when you made it.
All right, well, let's try it this way. Yeah, that's cool. I don't know why it's doing that. All right, well, I'll delete that guy. Oops, not that. Just that one part of that sketch. All right, now let's try this. There we go. All right, so all that does is just put a little notch in here, which if you think about from what we've done already, that's not the most useful thing in the world as far as chaining goes. But let's see if I can, I'm just gonna see if I can do this a little bit differently. Kind of have an idea. All right, so this is going to be 360 divided by 5. So that's gonna be 72 degrees. We're going to well, it really doesn't want to let me select that. All right. So that's fighting me. I don't really want to deal with that anymore. So what we're going to do is we're going to change this to Mastercam. So basically, in order to do this in Mastercam, we're going to do the same thing. Right, so we would have 90 minus 360 divided by 25. All right, so I basically have almost the face of a clock. Then I could do a transform, rotate. And again, we do 360 divided by 25 as our angular spacing. Oops, wrong direction. So let's say negative. There we go. So we got 1, 2, 3, 4, 5. There we go. And then we can select all of these, and then do another rotate. And now we do 360 divided by 5, negative 360 divided by 5. And we could increase the instances of that. And then, then what we have is basically what we're looking for. And then from here, this is actually super easy to chain, right? We would just do a contour, could select all of it. Say my starting point's in the middle. I'm going to, well, let's do the outside too. You know, I could select my tool, turn off my cutter comp, all that stuff, and turn off lead in, lead out. Don't forget that. But basically, that's the engraving that we would be looking at. So hopefully that makes sense. That's actually the first time I've ever tried to show you guys how to extrude that, do an extruded cut on it. And the reason why is because if you think about it, it's really not that useful to have that on your model as far as machining it. Because all you can really select is you're kind of stuck selecting the bottom of that groove anyway, which is going to basically be the same thing as this, just, change our linking parameters. And now it's the exact same tool path as that other one. So, so any questions on any of that?
So
Not so far.
All right. So everybody making progress on the projects this week?
Yeah.
Yeah, I've got a little more time over the weekend, so I typically tend to, postpone the majority of the work that I do till the weekends on, Mastercam and SolidWorks. But I've got, the tooling U done and all that jazz.
How is the tooling U? What do you guys think of the tooling U stuff?
It's so repetitive. Like,
Is it?
yeah, it is.
the questions that they ask, like you'll watch an episode or whatever, but the questions they ask are from like the first lesson some of the time, and it's just goofy. But it's got information in there, I guess.
I mean, is there useful stuff in there?
Yeah, I learned some
Okay.
stuff that I didn't know already.
Okay.
Yeah,
Good.
quite a bit.
I mean, that's kind of I think the tooling U is much more geared for the other classes as opposed to ours. I mean, I know there's plenty of CNC stuff in there. There's plenty of grinding and different mechanical concepts. So I think it's pretty good for like the advanced class, CNC advanced and intro, but for CAD CAM, there's really not much on there. But I was just kind of thinking that some of the, I really think that, I talked about it before. I really think the additive manufacturing is going to just get bigger and bigger and bigger, and robotics and all that stuff. So I was just thinking maybe some of it might be useful in the future.
Oh yeah, it's definitely
Mm-hmm.
it's interesting
Yeah.
for sure. It's just different, I guess.
Yeah, and if it's, I'm trying not to. I mean, the lesson plans, as far as I thought, didn't seem like 1 or 2 a week was too much in addition to this stuff. So if it does feel that way, please let me know.
Yeah, I mean, like I said in the email last week, I've been just
Yeah.
working ahead. Like when we had the whole week off, I just did like 4 or 5 extra, and
Yeah.
I
Good.
think that's a good method to go about it. If you can just get ahead in that,
Yeah.
you don't even have to worry about a due date.
Yeah, and then it gives you your weekends for the
Right.
SolidWorks and Mastercam. So cool. Great. All right. Well, that's all I had for you guys today. So
Alrighty.
hope you guys have a good day. Hopefully the Emperor visit goes pretty well.
I was wondering what that was. When it's
Uh,
small and minimized, I couldn't know what exactly was going on.
Yeah, I got the stormtroopers. Palpatine's going to come and force choke some people. Be a good day.
Yeah, I noticed yesterday you were in the office.
Yeah, yeah. I've been a little bored here, so I've been downloading some Zoom backgrounds. The videos are really hard to find, but you can use any picture in the world for your background. It's pretty funny. But all right. Anyway, have a great weekend, guys.
Yeah, you too.
Yep, you too.
All right. See ya.
Yep.
Bye.